Hello guys and welcome back. So in this section we'll talk about change detection mechanism in Angular. Now change detection is a process of capturing the internal states of an application and then somehow projecting these changes to the user. Okay, in simple terms you can say that it's basically a way of synchronizing your model with the view. Okay, now if you come from an Angular.JS background, you'd already know that change detection in Angular.js is generally triggered when there is an asynchronous task. Okay, now by asynchronous task, I mean these three types of tasks. They can be DOM events, they can be XML HTTP requests, or they can be the timer functions like the set timeout or the set interval. Okay, now Angular uses the concept of zones that was inherited from a language called Dart, and Angular comes up with its own zone named NgZone, where and everything that we code is generally run inside a zone. Okay, so every component has its own change detector, and we can have access to that change detector by injecting a dependency known as the ChangeDetectorRef. Okay, now how exactly does this zone work? So what happens is that a zone is forked, okay, and then the run method on that forked zone is called, and whatever function or whatever asynchronous task or code that we are writing would be run inside that particular zone. Okay, so here is one of the examples of that. So whenever there is a set timeout function call, that would be run inside a zone. Okay, some of the other examples of such a zone aware say function are these, like so, where we are doing something like making the functions like add event listener or remove event listener or a promise or a set timeout zone aware. Okay, so we are making these functions right here, and then we are assigning those functions to the actual functions that are going to be called whenever an asynchronous task is run. Okay, so this is the whole process of monkey patching that whole asynchronous task handlers by the zone aware asynchronous task handlers. Okay, so whenever there is an asynchronous task now, Angular will be able to know about it because it would run in a zone, and then it has some flags like in the zone flag that you can see right here, in which way Angular will be able to know that a particular function is running. Okay, now zones can be created, they can be forked, or they can be extended as well, and it contains some functions like onZone created, which would be run whenever whenever zone is forked. It has functions like before task, which would run before a particular function is executed inside the zone.run function that we have seen here. Okay, then we have the after task that runs whenever a particular function is completed running in that zone. And finally we have the on error function that gets called if the function that is running inside the zone.run function throws an error. Okay, but we can also extend a zone to add or include our own methods, and that's what Angular has done. Okay, so Angular has forked the zone and it has extended the zone API to add its own functions like on unstable, on micro empty, on stable, and on error. Okay, so on unstable will notify us whenever a zone is entered or whenever some code is entering the Angular zone. On micro task empty would notify us whenever there are no tasks pending or there are no asynchronous tasks that are pending in the queue. On stable will notify us whenever the last task in the on micro task empty has run, And finally, on error will notify us whenever there is an error. Okay, now NgZone is something that can be imported from Angular core. And if you want to run a function outside the Angular zone, then you can run that inside this run outside Angular function. Okay, and if you want to re-enter the Angular zone, then you can invoke it by invoking the ngZone.run method. Okay, now here's what happens during the here's what's happen here's how the whole thing works. Okay, so since Angular is running all the code that you have written inside its own zone, it will know whenever the on micro task event is fired. Okay, and whenever that is fired, Angular will execute a function named tick that will eventually start the change detection mechanism. Now, every component that we have in Angular has its own change detector reference that you can have an access to using the change detector ref dependency that can be injected inside your component. Okay, and then you can also change the change detection strategy. By default, it's default. There are two types of change detection strategies: default and on push. Default will do change detection whenever, or it will let's say it will detect changes each and every time, but on push will detect changes only when the reference of the input property has changed. Okay, so let's see what I mean by that. Okay, let me just get rid of all this code here. All right, so now let's say that I have a parent component and I have a child component, and then let's say that I'm passing some value, let's say a user, which is an object that has a name property which is of type string. Okay, and let me just name this as say Jacob. Okay, Uh, now let's say that I want to create an input property inside this child component. So to create an input property, I'll decorate a property, let's say user, with the input decorator, and this would again be of type object with a key named name, which is of type string. Okay. Now let's say I want to use this child property, or I want to use this child component, so I'll do something like app-child to use its selector, and now I know that it has a property, an input property named user that I can assign to in here. So I'll do that like so. Okay, and let's just save this as of now, and since we'll be receiving the user property here, I can simply print that out onto the view or the template of that child component by doing something like this. I'm using string interpolation syntax here. Okay, now if I go to my application here, let's just clear this off, and I'll get rid of this notification and reload this. I'm getting an error. Let's see what's the issue here. Let me just go back to the code and see what's happening. Okay, looks like I didn't save the file here, so I'll just save it and let's go back. Okay, so now Jacob got printed to the screen, right? Now let's say I have these two buttons here. Okay, and with the first button's click, I'll change the property. With the second button, I'll just simply change the object. Okay, so I'll bind to the click event of it, and I'll call change property method here, and on the click of this I'll call the change object method here. Okay, now I need to define these methods in my parent class, so change property and change object. Okay, in the change property method I'll just change the property of the user method, the name property of it. I'll change the name to Sam, and then in this I'll simply change the object itself. So I'll create a new object with a name property of, say, Tom. Okay, and let's just save this, go back to the application, and let's click on the change property here. Now the change property button should rename this to Sam, that it did, and the change object should change the name here to Tom, that it did. Okay, now this is by default that's happening. Okay, so by default, if we haven't specified any change detection strategy, it is set to default. Okay, this is the default. It means that the change detection mode will be initially set to check always. Okay, um, now it was default anyways, so if I save this now, this wouldn't change the behavior. If I click on change property, it will change the name, and if I click on change object, then it will also change the name. Okay, but let's say I wanted to have the change detection only when the actual object was changed. Okay, so in this case, okay, so in that for that, what I can do is change the change detection strategy from default to on push, and let's save this now. Okay, and now if I click on the change property button, nothing is happening to the name here. Okay, but if I click on the change object, it changed from Jacob to Tom. Okay, now setting it to on default, or sorry, on push, generally saves you a lot of time, and it generally improves the performance of your application. So it is advisable that whenever we are trying to tune up the speed and performance of our application, we should definitely check this out and use on push. But then for on push, we'll have to use some other libraries like Immutable.js that will always create a new instance of an object whenever a particular field inside that object has changed. Okay, so anyway, this was the different ways in which change detection can be the change detection strategy can be changed. Okay, so now let's also quickly see what is the use of the change detector ref. Okay, so suppose there is there is a use case wherein any asynchronous task, or if there isn't any particular say DOM event that is actually changing the data, but the data is still getting changed. Okay, so in that case you'll have to manually run the change detection. Okay, so to do that, what you can do is you can inject the change detector ref as a dependency into the component in which you want to detect changes, and then you can call the detect changes method uh, on that injected dependency, and that way you can detect changes even if there isn't any asynchronous task going on, but you still want to detect changes. Okay, I cannot really think of any particular example right now for this, but there might be a use case wherein you might require this, so just for the sake of knowing it, I'm telling this to you. So you can import change detector ref from Angular core and inject it as a dependency. What I mean by that is, in the constructor you can do something like this. This would be of type ChangeDetectorRef. Okay, and ChangeDetectorRef is something I've imported from Angular core. Now in the NgOn init say, if there is a change or if inside some other function there is a change and you want to manually run change detection, then you can do something like cdref dot detect changes. Okay, and this will run the change detection cycle for you. Okay, so that's where it can be used. Apart from that, there's just one last thing called the change detection tree. So as you can see in this example, change detection works from the top level to the bottom. Okay, as you can see from the arrows here. So say if this particular node or this particular component in this component tree right here changed, it will select this particular path until the root of this component to be checked, and then when change detection is performed, it will start from the root component and then it will trigger down to this particular path. Okay, and this is generally the case when you have set the change detection strategy to on push. Okay. All right, so this was it regarding change detection. Now, in the next sections, we'll talk about some other building blocks of Angular, like say a directive or a service or any other building block of that sort. Okay, so I'll see you in the next video. Thanks a lot.